Now that we've looked at the structure of a program, we need to look at some of the rules of writing Java statements. So that's Java syntax. So I know we looked at declaration, we looked at main method, but we didn't look at line 3, which is our first statement. So what is a statement? It's a single unit of execution, which can be a declaration, an expression, or control structure. So each statement in Java typically ends with a semicolon. This is one of our biggest rules. And I can tell you, learning Java very early on in my programming journey, uh, that is typically the biggest mistake that people will make. You just forget the semicolon. And when you're writing code really quickly, last minute, I can tell you I procrastinated, as many of you will in this class. It's easy to miss those semicolons. So this is going to be the first thing you want to watch out for when you're writing your code. Always end every statement with a semicolon. So this is similar to other languages like C and C++, different than some other languages like Python, which actually has no end symbol. I think that's why they choose Python a lot for beginner programmers, because maybe the syntax is a little bit easier, at least in my opinion. But Java is still a great program to learn on, I have to say. I can tell you, I learned on C++, and that one's a little bit, as we discussed, it's kind of in the, close to the mid-level, right? Intermediate level of programming languages. So yeah, that one wasn't as fun to learn on. But, trial by fire, I don't regret starting on C++. So in the next lesson, we're going to learn about declaration statements, so what those are. But at least in this lesson, we're going to talk about the most common expression statement, or also known as the print statement. So that's used to output information from your code. We've talked about input because our code doesn't have a proper interface. Again, that's the screens, the icons, the buttons. It's going to be a very simple interface. This print statement is extremely useful. Later, once you guys become really awesome software engineers, potentially in the future, then of course you'll be able to make like really cool buttons and screens that work with your Java code. But for now, we're going to be stuck with our kind of ugly graphical user interface, or sorry, command line interface, which is basically just text on a console. So yeah, expression statements perform operations such as calculations, method calls, or assignments, things that we'll discuss later in the class. So don't feel like you need to follow every single thing on this slide. Just know, end in semicolon, every statement, and the most important, the most fundamental statement in any programming language is the print statement. So in Java, output is commonly displayed using the print statement, which is kind of funky. We have to use system.out.println statement, which prints text or data to the console. Well, what is the console? It's the text-based interface that allows you to interact with the computer program by typing commands and receiving text-based output. So if we go back to IntelliJ, for example, let me go to IntelliJ. And I open my new project here. When I hit run on my program, this is the console, sometimes called the terminal even. When you run it from the terminal, that's also kind of a version of the console. But when you have your run, you have your separate run console here. So this output was made possible because of the system.out.println. And now something we need to discuss with statements is these, in the case of functions like the print function, the print statement, is these parentheses. When you see a right-facing parentheses, you're going to have to end it with a left-facing parentheses. When you see a right-facing curly brace, you got to end it with a left-facing curly brace. And notice when I click on the curly brace, it highlights the matching pair. Common error is forgetting that curly brace, which we'll discuss in this section on syntax. But returning to our slide here, yeah, the system.out.println is what makes it possible to print messages to the console. This is going to be our interface. This is going to be how we talk to users. This is how we communicate with users. This is how we also take input from users eventually, once we learn user input. So text inside the print method must be wrapped in double quotes. So notice I can't just write your message here. I do have to wrap it in quotes, which we'll discuss in greater detail in the next lesson when we talk about data types and primitives. So yeah, just know for now, if you have to type a message out, you got to do those double quotes And then you also need your parentheses right before the quotes. The ln after the print indicates that a new line is added. Not sure why it's reversed. Definitely, if you would want to explore the reasoning behind that, right? Definitely let me know, because I'm not sure why it's ln instead of nl, right? For example. All right, so that indicates that a new line is added after the output. That's really useful because, again, going back to IntelliJ, if I don't put ln and I hit print, they're going to print on the same line. Usually when you're printing out statements, for the most part, you want each one to be on its own line. Not always, but sometimes, most of the time, especially when we're just starting out. So again, if you remove the ln, that's going to do the same thing, but just no new line at the end. Just like when we saw that output on the same line. And again, console is that text-based interface. That's going to be the interface for all of our programs in this class. We're not going to do any GUI, which is graphical user interface. Graphical user interface is exactly what our computer has, like these icons. Right now that I'm on my slides, this is an interface, right? I can go to the next slide with these buttons on the interface. We're not going to have any fancy, creative, artistic stuff like that. We're just going to be good old-fashioned text-based interface, command line interface. All right, so comments. We've already talked about conventions and how conventions make our code. We follow certain rules, right, that are not like written in stone. Like you don't have to do those things, but they're a good idea, right, if you want other programmers to be able to read your code. I'm going to be reading your code, right? So you're going to want to make your code easy to read. Another way to do that, another great convention, which really should be written in stone in some ways, right? But of course, you don't have to do this, is comments. So comments are used to add explanatory notes or remarks to your code, making it easier for others and yourself to understand the code. I can tell you when I was writing massive, amounts of code for my professional role as a full stack engineer, a lot of the comments I wrote were for myself, because when I would go back to the code and would have to make changes, improve it, test it, I need to understand what it was doing. And the only way that was possible is by writing little comments for myself. They're cool because they're ignored by the compiler. You're never going to get a comment error. This is purely for documentation purposes, purely for other humans to read, not the compiler. So the compiler is always going to ignore them as long as we follow the right syntax. So what is documentation? That's just the written information that explains how a program, system, or software works. This is one of the key jobs of any programmer, any developer. You have to document your code. Otherwise, it's not going to make sense to anybody else. And for the most part, if you're writing serious software, you're working in a team. If you're writing open source software, even on your own, and you eventually hand it to other people, you want them to understand what's going on with your code. Just writing just the code itself, you can certainly get descriptive, right? We're going to talk about like conventions and naming variables and methods. Those could be great ways to document your code. But at the end of the day, comments are going to be that, really human readable messages that are going to help explain to people what the heck your code is doing. So there are different ways to write comments in Java depending on the length of the comment and the purpose. So the most basic type of comment is single line comments. You just do double slashes. These are for short explanations or notes that fit on a single line. So if it's a short comment, nothing too long, you can use the double the double forward slash. So that's going to be where your question mark is. You hit shift question mark. That's how you do a slash. Two of those, and that'll be read by the compiler as a comment. So the compiler is going to see this and say ignore. For the second line, system.out.println, it's going to execute it. But then once it gets to these double slashes, this print message, it's going to ignore that. So it won't trigger any errors. So everything after the double forward slash on the same line is ignored by the compiler. If your comment is longer, it's going to take up multiple lines. You have to use a multi-line comment. So slightly different structure here, slightly different syntax. You're going to use a forward slash and a asterisk or star. And then you're going to end it with the reverse. You're going to do the asterisk first and then the forward slash. So everything in between will be read by the compiler as a comment, so it'll be ignored. So everything between these slashes, notice the placement of the asterisk, one on the right, one on the left, will be ignored by the compiler. So this is for longer explanations. So in this example, multi-line comment that spans several lines. Now, some of the most important comments are JavaDoc comments, which, if you remember, JavaDoc is part of the SDK download that we have. It's a tool. So JavaDoc tool can generate HTML documentation from these comments. So when you write these comments, they actually have very similar to multi-line, but notice the extra asterisk. You can actually generate a really cool guide, and it has a really nice like style and interface because of JavaDoc. So even though you're just writing it in this like text-based editor, it's going to generate like a really nice graphical documentation. We'll explore that much later on when we get to classes and full-fledged programs in Java. But just for now, we're going to give a shout out to JavaDoc comments, probably the most important. Another really important rule in terms of Java syntax is that Java is case sensitive. That means lowercase and uppercase letters aren't treated the same. So variable names, method names, class names, everything that you're naming in Java, you got to be consistent with that capitalization. My class is not the same as my class, or my class. Now, if you're just listening to this video, that'll sound really confusing. But if you're obviously seeing the video, then you'll notice that I did different capitalization for all these my class versions. So this first one I capitalized my and class. The second one I only capitalized my. The third one only class, and then the last one no capitalization. From the perspective of the Java compiler, these are all different. So make sure that when you are naming things, you are consistent. That's a very, very, very common mistake. A very common bug that you'll introduce into your code is just inconsistent casing. So really be careful. So more on common errors. So we've already discussed the semicolon. I've kind of touched on the mismatched parentheses or braces. Once you see a right-facing curly brace, parentheses, bracket, you got to make sure there's a corresponding left-facing one. And as we already saw in the IDE, it gives you that little extra cue, that little extra help, that when you click on one of those braces, parentheses, cues, I'll do it one more time, it's going to highlight the other one. And if I'm missing one, it'll trigger that error, just like we saw before when I was missing the semicolon. And then, of course, misspell words and inconsistent casing. Maybe some of us aren't, the fastest typers. I can tell you, I've met a lot of programmers that are fantastic and maybe aren't super fast at typing. That's totally fine. You are going to want to get faster and more accurate with your keyboard skills because misspelled words is really, really common issue, as well as inconsistent casing, which you can definitely suffer from these bugs and errors a lot if your keyboard skills are not up to par. But of course, as we're writing code, right, you'll definitely get some practice, but definitely invite some of you who maybe could improve, definitely do some keyboard practice outside of the class.